These formulas for interest are also on the back on 36, so you have to know when to use which formulas. And here we're accumulating interest, which is the first three of those interest formulas. Compounded continuously is when we get E. So we're using the formula A equals PE to the RT. The principal is 260. The rate is 0.09. And T is 19. You just plug all that in and you should get 1437.53. This next one, we're compounding semi-annually, which means we have to use the other one, the one with the R's and the K's. Looks like this. Oh, that was supposed to be P. So that's 1000. 1 plus 0.1 over K, which they tell us is 2. 2 times T. Plug it in. Totally not the right answer. Hang on, I was looking at the wrong problem. 2925.26. Alright, so these are some more formulas that we have on our back sheet. We're doing future value on 31, and for that formula you do need to know that I equals R over K and N equals KT, which I just wrote backwards, but oh well. So this formula is kind of complicated, but they gave us everything we needed. R is 350. 1 plus I is going to be 0.7 over 4. N is 4 times 8 minus 1 over 0.07 over 4. Make sure you can plug this into the calculator correctly. So if your calculator doesn't make the fancy fractions, keep in mind that the top and the bottom need parentheses, and I would also put another parentheses maybe around this whole fraction just to make sure that it does it right. And then you probably should have a parentheses around 4 times 8, or just do 4 times 8 and put that in instead. If you do all this correctly and stuff, you should get this. $14,844.27. Now present value, which is a slightly different formula. So present value equals 710.17 times 1 minus 1 plus 0.06 over 12 to the negative 9 times 12 over 0.06 times 12 divided by 12, I mean. Okay, so similarly, I'd put the top in parentheses, I'd put the exponent in parentheses, bottom in parentheses, and then like a big parentheses here. And you should get 59,15249. Now, here is periodic payment, which is present value, by the way. If it's a loan, it's present value. If it's investment, then it's future value. So now they're telling us what that value is. It's 16,000. We're trying to find R. So that makes a bit of a difference. And it looks like I went ahead and multiplied the 5 and 12 together to put negative 60. So basically what you want to do is figure out what that is on the right side. And you should get 51.7256, and then do 16,000 divided by that and get R equals 309.32. 34 says determine the doubling time of the investment, and it says $1,000 at 9% compounded quarterly. Well, the formula for that is the second interest formula on there. If we want to know how long it takes to double $1,000, we're talking about how long does it take to get to 2,000, because that's twice as much, right? 1 plus 0.09 over quarterly means we're compounding 4 times a year, and we're trying to figure out how much time it takes, so t is our variable. So we solve, anytime it's doubling, when we divide that number over, we should end up with a 2 here. This is 1.0225 to the 4t. Now, we want to rewrite this as a logarithm because our variable's in the exponent, so it's log base 1.0225 of 2 equals 4t. So you figure out what this is using your calculator, log base 2 over log 1.0225, and then divide it by 4. T equals 7.788. Annual percentage yield is the last interest formula on there. You can cancel out the p's right off the bat so that you just have 1 plus x equals 1 plus r, which is 0.075, over k. Quarterly means 4 to the 4 times t is 1 because we're talking about annual. So we just have to figure out what this is on the right side and then subtract 1. So x equals 0.0771, which as a percent is 7.71. There you go.